All right, let's start off with a couple of review problems. We want a graphed function, label the vertex and axis of symmetry. These are all quadratics that are being transformed. The first one looks like it is going left 4. That one would be going right 2, down 6. This one is going to be going left 3, down 3. And it's going to be smushed in by a factor of 5, also a reflection. So, what are we doing today? We're going to be using the graph of a quadratic to determine the number of real solutions. So, there's a couple different ways that you can use to solve quadratics. We're going to be talking about today. We're going to talk about graphing, where you find your x-intercepts. Using the square root, where you take the square root and solve, or by factoring. So let's do the first one. We're going to solve this by graphing, and we have done graphing before, so that should be pretty straightforward. Find your vertex, plot the points, and on this one, your intercepts are at -2 and 3, so those are your solutions. -2 and 3. Graphing, I think, is the least accurate way of solving things, because if your graph is off by just a little, it really affects it. You can always check and make sure you've gotten the right answer by plugging in your answers back into the original equations. So on B, you have to make sure that it's set equal to 0. You graph it. And here it's only touching one time. That's what we call a double root. The x-intercept is -1. And we're done. All right, these are you try. I would take a second, pause the computer. Let's see what you come up with. Yeah, on number 3, when you graph it, there aren't any x-intercepts. Also, if you really wanted to, you could put these into Desmos and graph them. Going to be a little bit more accurate than graphing them by hand, and then you can find out your x-intercepts there as well. Oops, looks like I gave you the solution to the first one, the first step. We want to solve these by taking the square root. So on the first one, we have just written the equation down. Add 31 to both sides. Then we're going to divide by 4. Our whole goal is to get that x squared by itself. Once you have that x squared by itself, then you can take the square root, and you're going to get the plus or minus square root of 20, which is the square root of 4 times the square root of 5, which would be plus or minus 2 radical 5. And that's going to be your solution. For B, you write the equation, subtract 9, divide by 3, and you can't take a square root of a negative and get a real solution, so there are no real solutions. Eventually, we're going to be taking the square root of negative numbers, and it's called the imaginary number set, but we're not quite there yet. On the last one, again, we're going to want to get rid of that square, but first we have to get rid of that fraction. You can do that by multiplying by the reciprocal, which would be 5/2. Now you can take the square root and subtract 3. We want to make that radical look a little bit nicer. So radical 25/2 is really the same as radical 5 over radical 2. And then you want to rationalize that denominator, because radicals are not allowed in the denominator. And you're going to get -3 plus or minus 5 radical 2 over 2. If you had plus or minus 5 radical 2 over 2 minus 3, I'm okay with that as well. And keep in mind that plus or minus means that you're going to have 2 solutions, both the positive and the negative scenario. All right, on these are, again, you try. Take a second, pause it, try these out. I'll give you a hint on the first one. Start by subtracting 14 and then multiply by the reciprocal, 3/2. All right, let's talk about the zero product property. This is what you're going to use when you're factoring. Something times 0 gives you the result of 0. So here, if we have A times B equals 0, then A has to be 0 or B has to be 0. One of them has to be 0. So we're going to solve this one by factoring. Subtract 45. Then you're going to factor, find two numbers that multiply to negative 45, add to negative 4. Then you set each of those factors equal to 0 using the zero product property. X is going to be 9 or negative 5. And if you were graphing, that's where they're going to cross your x-axis. Try this one on your own. Take a second and pause. I think this one is a little bit harder on the factoring because it's got that coefficient of 2 in front of the x squared. So on this one, you have to solve by factoring. Two numbers that multiply to give you 35, add to give you 12. Here, you're going to have to subtract by 2. When you find the zeros of a function, that's saying what are your x-intercepts. Look for a GCF for number 9. All right, go for it. Yeah, number 10, it looked like it was a tough one to factor, but it was actually a perfect square trinomial. 2x plus 7, quantity squared. All right, everybody's favorite word problems. A monthly teen magazine has 48,000 subscribers when it charges $20 per annual subscription. For each $1 increase in price, the magazine will lose 2,000 subscribers. What is the maximum annual revenue and what is the maximum annual, or what should they charge to get the maximum, and what is it? Okay, so this seems like it's going to be a tough problem, but it's really not that bad. Let's kind of enlarge that so you can see that a little bit better. That's much better. So we're going to start by defining our variables. X is going to be the price increase, and R of X is going to be your revenue. So your revenue is going to be the number of subscribers times the subscription price. And that makes sense. The amount of money you make is the number times your cost. Well, our revenue is R of X. The number of subscribers is going to be 48,000 minus 2,000X because you're losing $2,000 per number of increases. The subscription price is going to be 20 plus X because the price is going to be going up. What we're going to have to do is FOIL that out. It looks like they got a GCF out first and then FOIL. What am I talking about? We don't have to FOIL. They factored for us. We're making this too hard. So we know our intercepts are at 24 and at negative 20. The maximum or minimum is going to be in between those, which is 2. So that means that you're going to have 2 price increases of $1 each, or $22. Now we need to find the maximum annual revenue. You plug that 2 in, get 968,000. Okay, this is just kind of a what if. You'll do it the same way. Take a second, try that on your own. Let's see what you get. This is a fun one too. And this one is nice because they give you a nice visual of it. For a science competition, students must design a container that prevents an egg from breaking when dropped from a height of 50 feet. We want to write a function that gives the height of the container after t seconds. How long does the container take to hit the ground? Find and interpret h of 1 minus h of 1.5. So the initial height is 50. We're going to write that function. T is plus or minus 1.8. You use a calculator to get that. You throw away the negative because you can't have a negative time. So 1.8 seconds later, hits the ground. To find h of 1, you plug 1 into that function, h of 1.5, plug that into the function, and then you're just going to subtract them, and you get 20. So between that 1 and 1.5 seconds, the container fell 20 feet. And that is a reasonable answer. You always want to check yourself at the end going, does that seem reasonable? All right, that's all we have for today. Hope you enjoyed.